All right, so this is going to be the lesson on the video lesson on 7.1. It is the very first topic in this new unit, and our new unit is something called circuits, right? And throughout this unit, we're going to learn about, well, how does electricity work, right? How does electricity flow? How do we measure the amount of electricity flowing from one point to another, right? And how do we build circuits, how we build series circuits, parallel circuits, how we use voltmeters, amp meters, etc. And so let's take a look at this do now. And the do now question is really just asking, well, you have two tanks, and which tank is going to have the highest water current? And highest water current being, well, the most water flowing. And we kind of take a look at the two. Most of you guys are going to say the left tank. The left tank being because, well, there's a larger pipe, there's more water flowing through the pipe at any given point in time. And so moving on, here's an example of a simple circuit, right? And in a simple circuit, you see a battery, you see wires, right? You see a switch, and you see a light bulb, or really just anything that uses electricity. For example, your calculator uh, or the battery inside your phone. Moving on, now a lot of you guys already see the wires that electricity flow through pretty much every day, right? If you kind of go outside and you look at the wires outside, well, all the way at the top, you'll see electricity. All those wires on these poles allow electricity flow from one point to another. And that's how your home gets electricity, right? Because these wires are connected to your home. And well, what is electricity? Electricity is the flow of electrons through wires. Right? You can see that here, right? So the electrons flow from the negative side of the battery to the positive side. But then on this top right hand image, well, what does it say here? Conventional current. Well, what is that? Well, when Benjamin Franklin was first researching electricity, he thought positive charges were the one that was moving through wires, right? So protons. He thought the protons were moving. But that's not the case, right? As we discovered later on, we discovered that, well, electrons are the ones that are moving. But because of the basics of electricity was established already in Benjamin Franklin's time, we kind of still use that convention that, well, positive charges are the ones that are moving. But for reagents physics, you don't really have to care about convention all too much. You just have to know that electrons are the ones that are moving, and the electrons move from the negative side to the positive side. And here we get to the formula for electric current. Electric current is the amount of electric charge Q that's flowing through a period of time T. So I is equal to Q divided by T. And I is measured in amperes, or abbreviated as A, and Q is, again, your electric charge measured in coulombs. If you take a look at the GIF on the bottom right hand corner, you'll see that, well, the more charges that are flowing through a wire at any given point in time, well, that means you have more current, right? You have a lot more charges. And and to the right, you'll see that, well, if you don't have a lot of charges flowing, well, you're not going to have as large of a current. All right, so take a look at this practice problem right here. And so that says the current in a wire is 5 amperes. Calculate the total amount of charge in coulombs that travels through the wire in 36 seconds. So just by reading it off the problem, right, the current in the wire is 5 amperes. So now that 5 amperes is a measurement for current, right? So that's going to be I. So I is 5A. You want to find out the total amount of electric charge. So you're looking for Q. And then you're given the time, right? The time it takes to travel through the wire is 36 seconds. Or rather, you're just measuring the amount of time. So So I is going to be 5A. Q is going to be what you're solving for, right? T is going to be your time, 36 seconds. So given the formula I is equal to Q divided by T, you're going to substitute all your numbers in. right? Then you're going to multiply by 36 seconds on both sides, and then, well, 36 times 5 gets you 180 coulombs. Now, moving on to the next question right here. 2,700 ohm resistor. Now, that's something you don't have to worry about right now. That's 2,700 ohm resistor. It's something called resistance. But we're going to talk about resistance next topic. Draws a current of 2.4 milliamperes. Total charge that passes through the resistor in 15 seconds is what? So already you can see that, well, your current is measured in milliamps. Well, a current is measured in amperes. So what you need to do here is you need to convert this milliamperes to amperes. And if you go to your reference table, you look at the powers of 10 chart, you'll realize that, well, milli is 10 to the negative 3. So your current here is 2.4 times 10 to the negative 3 amperes, right? As you guys can see here, right? So 2.4 times 10 to the negative 3 amperes. Q is what you're looking for. T is your time, right? So it's 15 seconds. I want to do the same exact formula, the same exact process. We're going to multiply, we're going to substitute, plug everything in, multiply by time on both sides, and then we get our answer. Now, moving on to the third question. So this third practice question is fairly difficult. It was not fairly difficult. It just requires one more step. So it begins by, what is the current in a conductor if this many electrons pass through a given point in the conductor in 10 seconds? So you're looking for current here. So you're looking for I. So we're no longer looking at charge. We're looking for I. But this amount of electrons right here, this many electrons, well, that can give you a charge, right? Because we're given a time here. Time is 10 seconds. Well, what are we missing to solve for I? We're missing Q. So we have to convert this many electrons into charge. And well, how do we do that? Well, we know that one electron has 1.6 times 10 to the negative 19 coulombs. So what we're going to do here is we're going to multiply 3.15 times 10 to the 18 by 1.6 times 10 to the negative 19 coulombs, and we get our total charge, which is 5.04 times 10 to the negative 1 coulombs. Do we have time? We're going to solve for I. We'll use the same exact formula, and then we'll get our answer. And at any point in time, feel free to pause the video, right, or go back to really kind of look over the problem, see if you can do it yourself. See if you can do 3D yourself, right? And then you can check the answer in the next 5 seconds. But you should probably just pause the video, and then I'll move on to the answers right now. This is the answer. Right? This is the answer. You're doing the same exact process. Let's go to the final practice problem. Again, feel free to kind of pause the video right now if you kind of want to solve this question yourself. Now moving on. And this is going to be your answer. Make sure you're converting your minutes to seconds, guys. Make sure. All right, that's the end of the video.